Today we're doing lesson 7.9, use protractors to measure angles. 9.1 says, how large is a 1 degree angle? Where's your protractor at? A ray that turns all the way around its end point and back to its starting place has made a full turn or has turned 360 degrees. So if you think of me as the ray's end point, the point on the end of the ray, and this is the arrow, okay? And if I turn, keep straight in the exact spot and turn around and end up back here, I've turned how many degrees?
360.
360. So do you remember, it's been a little bit of time, but when we did equivalent fractions, and when we found out, for example, that if you have the fraction 5/10 or 5 out of 10, and you divide by the greatest common factor, so of 5, the factors are 1 times 5, and for 10, the factors are 1 times 10, and then
2 times 5.
2 times 5. So the greatest common factor, the biggest number that appears in both lists is 5, right? So if you divide 5 and 10 by their greatest common factor, you would have, what's 5 divided by 5? 1. And 10 divided by 5? 2. You would have 1/2. That's the simplest form, right? Remember, if we do it to the top? Okay, so we are going to turn all of these degrees into fractions because it says what fraction of a full turn is each of the following angle measurements. So how many degrees are there in a full turn?
360.
So that's our denominator. So the bottom number of a fraction, remember, is how much is in the whole. How many degrees are in one whole, okay? So we're gonna write down 120 over 360, write that down. Now, I don't wanna go through and list all the factors of 120 and 360. I want to use some reasoning to figure out what their greatest common factor is. And so I know using the divisibility rules, because they both end in a 0, I could divide by 10. But what I noticed right away is 12 and 36. Is 12 a factor of 36? Yes. And so that means that 120 is a factor of 360. So the biggest number that we can divide 120 and 360 by is 120. We have 120 kids divided by 120 cookies. How many cookies does each kid get? 1. Okay, now if I have 360 divided by 120, let's look at this first as a 36 divided by 12. How many groups of 12 are there in 36, Audrey? 3. And since we're dividing, you remember when we are multiplying, we bring all the zeros over. But since we're dividing, we say I've got 1 0 here, and that cancels out this 1 0 here. So that means that in 360, there are 3 groups of 120, right? 120 plus 120 plus 120 is 360. So 1/3, if a ray travels 120 degrees, it has traveled 1/3 of the full circle, okay? So I brought these out to kind of show you that this is 1/3. And if I take a protractor and line it up, put the bottom center at the vertex point and line it up, it is pointing to two numbers. It's pointing to 60 and 120. Now if I look at that angle, you see how wide that is? What kind of angle is it, Harbor? Obtuse. So if it's an obtuse angle and it's pointing to 60 and 120, I'm going to use the 120. So that means that if a ray travels 120 degrees, it's traveled 1/3 of a circle. So write this down as well. If we divide both sides by 120, we get 1/3. That means in a circle, there are 3 120-degree angles. Make exactly a circle. Okay, the next one that we're going to do is a 60-degree turn. I'm going to switch the color back and forth just so it's kind of easier for you guys to see. If we have a 60-degree angle, and we know our full circle is 360 degrees, what is the biggest number that you could divide both 60 and 360 by? Zerelda?
3.
No? Fisher?
60.
It is 60 because can you multiply 6 times anything and get 36? Yes. So we're going to divide both the numerator and denominator by 60. Of course, 60 divided by 60 is 1. And then if we just look at the basic fact of 36 divided by 6 is what? 36 divided by 6 is 6. And now our zeros cancel each other out, right? The 0 and the 360 cancels out the 0 and the 60. So that means this problem, all we have to do is 36 divided by 6. So that means in a full 360-degree circle, there are 6 60-degree angles, okay? And we can double check that by saying 6 times 6 60-degree angles, or 6 groups of 60-degree angles. 6 times 6 is 36. Bring over the 0, and you get 360. Okay? So that is all we're doing on this, is trying to figure out how many of these angles they give us would be in a full circle. Okay? On the next one, we've got a 45-degree angle. So to figure out if 360 is divisible by 45, or 45 is a factor. You guys know that circles are made from 4 right angles, right? And right angles measure what? 90. So if we cut each of these 90 in half, then it would be 45. So if we do this all the way around the circle, how many 45-degree angles make up a full circle? Harbor? 8. So on this one, we're going to do 45 out of 360. We're going to divide the numerator and denominator by 45. On top we get a 1, on bottom we get, what was it, Harbor?
8.
Okay. And that means there are 8 45-degree angles in a circle. Okay, next we have a 30-degree angle out of a full circle. And so I'm trying to figure out if, well, let me back up. Okay, so remember, second ago, we split our circle into 90s, and then we split each of those 90s into 45. Well, if we have a circle that's split into 90s, can you split a 90-degree angle into 30-degree angles? How many 30-degree angles would be in 193? Because 3 times 3 is 9. So here's what I would do. Here's 1 30-degree, 2, 3 30-degrees. So 30, 30, and 30. So each one of these sections is going to have 3 30s, right? I think this is kind of a fun one. It's kind of putting together everything we've learned. All right, so let's count our 30s now. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So is 360 divisible by 30?
Yes.
It goes in 12 times. So we're going to divide the numerator and denominator by the greatest common factor of 30 and get 1/12. That means there are 12 30-degree angles in a circle. All right. Next we have a 10-degree angle. And we've talked about the 10-degree angles, I think, on the last lesson. So I know for sure that I can divide 360 by 10. Why? Avis?
Because, wait, can I just say something? So, 30 is a factor of 10. So, the answer is just going to be multiplied by 3. So, 12 times 3 is 36. The answer is 136.
You're right. You're right. And what's cool is, do you guys remember when we were learning about decimals and we were talking about how 1/10 is the same exact size as 10 hundredths?
Yes.
Because all you have to do is boom. All you have to do is boom. Okay? And that's going to get you a 1 on top. So that's essentially what Avis was explaining. So 10 divided by 10 is 1. 360 divided by 10 is 36. So Olivia, remember how when you multiply by 10, you add a 0 to the end. But if you divide by 10, you do the opposite. You take off a 0. Okay? Since we're dividing by 10, we just take that 0 off the end.
Oh,
Yes.
on the 1-degree angle, you just multiply by 10. Wait, I mean, since 10 is 10 times bigger than 1, then the answer is going to be 10 times bigger, so it's 360.
No, because remember this is a fraction. So think of it this way. You're making the connections in there, but that one was like, it wasn't connected. Okay, so if you're making a 360-degree circle out of 1-degree angles, how many are you going to need to make 360 degrees? Fisher?
360.
360.
Wait, that's what I said.
Oh, I thought you said 10.
Oh, it's 360.
Oh, okay. Good, good, good. So, there's only one, so basically one, let me get this back up here. We can't divide this one, right? Because the greatest common factor of 1 and 360 is 1. And when you divide by 1, you just get the same thing that you started with. So in 360, there would be 361 degree angles. Okay, so you guys have a protractor on your desk. You should all have a protractor on your desk. Oh, there you go. Thank you, Misty. Okay, if you look at your protractor, find the zeros. They're down on the bottom, right? How Does anybody see a number 1 by itself anywhere? No. So, but how does the protractor represent a 1? Fisher?
It's using like centimeters.
No. Avis? I'm listening. I'm turning the feet down. I'm loving that our feet is working now. Really exciting.
The little ticks around the perimeter is all 180 ticks around the perimeter of the protractor.
It's the little tick marks,
Yeah.
right? Okay. How is 1 shown on the protractor? One degree is shown by 1 tick mark after the 0. Okay. Now, if we were to count all those little tiny tick marks, how many would there be? Autrey? Yes. There are 180 little 1 degree measurements. We know that because it's a straight line and it's a half of a circle, right? Yes.
Is there such thing as a protractor that looks like
There is, I have one. I'll show you.
what?
I'll show you one in a little bit. Remind me when we're done. Okay. Freezing up. Here we go. Okay. So, a protractor with no numbers has been placed over an angle. The center, and don't put your protractor on this. I know you guys have one. That's not what you're supposed to be doing. You're supposed to be, so set your protractor up at the top of your desk so I can see it. This exercise is to teach us how we can measure angles without the numbers being there and how to correctly use protractors. So it says a protractor with no numbers has been placed over an angle. The center of the protractor is lined up with the vertex of the angle. The straight edge of the protractor is lined up with a ray of the angle. How many degrees is this angle? Okay, so they want you to count and find out on this one. So, remember those little tick marks represent what? Ones. Do you see how every so often we have a longer one?
Yeah.
What do you think those longer ones represent, Mary? 5s. So we go, so this is on 0. We go 1, 2, 3, 4, 5. Do you see another long one?
Yeah.
10, then 11, and what degree
12.
is this angle? 12, because it's laying on the 12, which means it's covered. Colton, do you see that? Okay. So, how many degrees is this angle? 12 degrees. And then we're not going to explain how we know. An angle an angle contains 31 degree angles as shown. How many degrees is this angle? Now they messed up on this one. Do you see what they did wrong?
Yeah.
Azeel, what did they do wrong? They didn't line it up correctly, right? You can still measure this angle though by counting the number of tick marks that are in the angle. So we can do it on this one because there's no numbers, but if there were numbers, it would be kind of confusing. So if we just counted, well, here's 1, 2, and then there's 5, so that'd be 7. And so let's count groups of 5 first. So there's 1, 2, 3, 4, 5, 6. So 6 groups of 5, and then 7 would be 30, 31, 32, 33, and then what's covered? 34. So this angle would be, oh, wait a minute. It says there's 31-degree angles. So what would that be?
39.
No, 30. So you've got 1, 2, 3, 4, 30. So I must have miscounted here. So let's see. So this would be 5, 10, 15, 20, 25, 30. I think that their counting is off.
Yeah.
But maybe they didn't expect us to do all that. Maybe they just wanted us to multiply. Because it says if it contains 31-degree angles, how many degrees is this angle? I think they're counting wrong.
Yeah.
Let's just say 30 degrees and move on. Okay. Use a protractor. Now they've put the numbers on the protractor for us. It says here are 4 angles whose sizes you may have estimated earlier. A protractor has been placed over each angle. Measure the size of the angle in degrees. So the first thing that we have to ask ourselves is, what kind of angle is this? Colton? Acute. It's not little, but is it less than 90 degrees?
Yes.
Yes. So it's smaller than a right angle, because a right angle would be right up here. So it's smaller. So that means we're going to use which of the numbers as our starting point, the 80 or the 100? 80. Since it's acute, we use the smaller numbers. You with me? Now, this isn't right on the 80 though. It's got it's one tick mark beside the 80. So what would that be?
81.
81. And I didn't know that at first. I had to look and see what the next group of 10 is. And since it's 90, I know this angle is between 80 and 90, just 1 degree away from 80. So that would be 81 degrees. Okay. On B, what kind of angle is this, Cameron? What kind of angle is B? Nope, I'm not asking you to measure it. I'm asking you if it's acute, right, or obtuse.
Acute.
Acute, because it's less than a right angle. It's less than 90 degrees. It's small. Okay, so if you notice, this angle is pointing to near the numbers 20 and 160. Since it's acute, Athena, which one are we going to pay attention to?
We're going to pay attention to
Evan?
20.
The 20. So since it's acute, we're going to pay attention to the smaller of the two. Now, if you notice, it looks like it's 2 marks past the 20, between the 20 and the 30. So what would its measure be, Harbor? 22. So B would be 22 degrees. Okay, on C, it is what kind of angle? Zerelda?
Acute.
Acute. So it's pointing around the 60 and the 120. So since it's acute, Athena, which number are we going to focus on?
120. I mean, oh my gosh. 60.
The 60. Okay, so it's near 60 degrees, but it looks like it's 1 degree away from 60. And what would it be, do you think, Evan?
59.
59. Who was thinking 61? 61? because normally when we go to the right, the numbers get bigger, right? Like on a number line. But on a protractor, some of the numbers are getting bigger as they go, but this other set is going down. They're getting smaller. So you have to look at what number, at the two numbers on either side that are the small ones. So we're looking at 50. So this line falls between 50 and 60. It's 1 degree away from 60. That means it's 59. Good job, Evan. Okay. 59 degrees. Okay. Then we have D. Okay, Macy, what kind of angle is D? Obtuse. It's a big obtuse angle, which means we're going to look at which numbers. The big ones or the small ones?
The big one.
The big ones. Obtuse, we look at the big ones, right? Okay, here we go. So this angle is right in between these two big numbers. So what is the measurement? Okay.
So remember, if you were counting up to 160 from 150, you would count 10 numbers, okay? Because that's 10 bigger. What's half of 10? No, double. Half of 10. So there's 10 cookies on the pan. You get half, Paige gets half. How many do you each get? 5. So that's what you add to 150. You add 5 more. So 150 plus 5 would be 155.
Does that make sense? Okay, so it's right between 150 and 160, 150 and 160 would be 155 degrees. Last one. Alina and Kieran are measuring an angle with a protractor. Alina says the angle is 80 degrees and Kieran says it shows 100 degrees. Why are they getting different answers and who's correct? So why are they getting different answers? Harbor.
I think one of them is saying that it's like two single and one saying it's like an acute.
Yep, that's exactly right. Alina says 80 because she thinks it's an acute angle. Kieran says 100 degrees because he's using the big numbers thinking it's obtuse. Who's right, Jackson?
Kieran.
Kieran's right because this angle is a little bit bigger than a right angle. Okay, so here's what we're going to write down and then we'll be finished with this. They got different answers. Because Alina thinks it's acute. And Kieran thinks it's obtuse. I'm going to go up here and write Kieran is correct. All right, I'm going to stop this.